Hi, it's Professor Adam. Let's talk about the important buffer solution equation, the Henderson-Hasselbalch equation. As we have talked about before, a buffer solution is a mixture of a weak acid and the salt of its conjugate base, such as acetic acid and acetate. We have previously learnt that buffer solutions can control pH changes. But how do we calculate the pH of a buffer solution and the ratio between the concentrations of the weak acid and its conjugate base? We use the Henderson-Hasselbalch equation. The Henderson-Hasselbalch equation is a rearrangement of the equilibrium expression for the ionization of an acid. It can only be used when the equilibrium concentrations of the acid and conjugate base are similar to their initial concentrations. This happens when the buffer pH is between 3 and 11. Above or below these pHs, and the acid or base will react too much with water. And when the initial concentrations of the acid and conjugate base are large, this means that small amounts in concentration will have a limited effect. The Henderson-Hasselbalch equation shows us that the pH of a buffer solution is controlled by the relative strength of the acid as expressed by pKa and the relative amounts of acid and conjugate base in solution. Let's look at an example. We are to find the pH of a buffer solution made from 2 grams of ascorbic acid and 2 grams of sodium ascorbate, made up to a 1 liter solution with pure water. We will use the Henderson-Hasselbalch equation, so first let's convert Ka to pKa. Next, calculate the concentration of the acid and its conjugate base. Filling this into our Henderson-Hasselbalch equation will give us the pH of the buffer as 4.06. The pH is lower than the pKa because the concentration of the acid is larger than the concentration of the conjugate base. Let's check comprehension.